Our next talk is ready. And now, our talk is about a bot move at Ball. Instead of paying 1 million a year for a tool that doesn't deliver, our speakers choose to build a recommendation system from zero. The following two speakers will share their stories behind the journey. Please give a big welcome to Ali and Renza.
Do you have a clicker? Do you have a clicker? Oh, okay. All right. Hello, hello. Good afternoon.
Good afternoon.
I hope you enjoyed the sessions and also the lunch, and you have still some energy for this presentation. Yes, I'm Reza, software engineer working at Bol.
I'm Ali, data science consultant to Bol from Big Data Republic.
Yes. In this session, we want to ride you along on our journey on how we built our in-house real-time recommendation system for Bo, what challenges we faced in real life, what sort of decisions we had to make, and how we tackled the issues, and what we basically learned from those issues. And a spoiler alert, at the end, we end up saving millions of euros for our company. I hope all of you are already customers of Bo, but in case you are not, if you check the website or the application, on the homepage, you usually see these colorful banners. So the top slot, indeed, we call them top banner, and the bottom one, we call them flex banners. We usually, during the campaigns, have tens of top banners and also like hundreds of flex banners available. And during the days, especially during the high season, we serve a couple of million requests per second. The journey of the customers mainly starts from the homepage, so with these many of the banners available, it's really important to ensure that we serve the best and relevant banner to customer and help them to have a better journey. At the time that I joined the team, the decision was already made that we will use a third-party cloud-based recommendation system called Pega. We used Pega, I think, for about a year and a half, and we even gone through a high season with Pega, but soon we learned a couple of issues, and the top three of these issues were the really expensive license and running expenses, the mediocre performance that even the marketing team was not really happy with the output of this recommendation system. And I think as a technical person, the worst one was that this recommendation system in general looked like a black box to us. As a technical team and even marketing team, and sometimes their own engineer really didn't know how the engine is working, why it was providing this specific recommendation to the customers. So in general, it was not tailored to Bol, because basically it was for banking solutions and was not really tailored for e-commerce. So the cost was really high, the performance was not satisfying, and we really didn't have control over it. So the company at the last year had to make a really bold decision: should we continue with this tool or build our own system? So the decision was already made, and our team became responsible for building a recommendation system from scratch. But at the time, we were only two software engineers with absolutely no experience with data science. This is the part that a floating team in Bol, which we call them Voyager, comes to the rescue. So there's a floating team with a few data scientists that, as their name implies, they look over different projects and teams and opportunities, and join the teams temporarily for a period, fixed period, and helps the teams to get up to speed, get some knowledge with data science, even build some data pipelines or MVPs and validate the idea of using data science. From the beginning, we promised ourselves that we will really start small. And also, we will do all the decision data-driven. So we created a really simple Kotlin service and deployed it by the end of the first week to production. And even we made the bold choice to send 5% of the traffic to the new service. And we really started simple. We just hard-coded a default top banner. We were not even supporting the flex banners, and there were no fancy models, AI, or etc. And over a couple of iterations, we were able to serve some random banners from the available banners. And in the meantime, our data scientists were busy cooking. So let's hear more about the fun part.
And this is where I joined the team. And I had to take over this project from Voyager data scientists, where, as Reza emphasized, wanted to start very small. So they built a very simple aggregation-based statistical model where they segmented customers into 48 different combinations and simply assigned average historical CTR that every segment of customers had made over each banner live. So we wanted to set a target for this statistical model to perform within 90% of the performance of Pega. So we were to A/B test this with Pega during the season of Bowl. So season for Bowl starts every year from October to end of December, end of the year, and this is a very critical time. And during this time, we wanted to focus on keeping this model in production reliable and stable, while other constraints were actually hitting us. The budget constraint that Pega should have been killed until the end of the year, and we still didn't have any mature data pipeline. So it made it very hard to keep the model stable. Actually, it needed much more effort. And we still had some bumpy data coming in. The events of views and clicks from upstream data coming to us was not reliable. And for those who are familiar with e-commerce data, our main primary metric that we optimized the model on was click-through rate, which is basically the proportion of clicks over views. And we still kept an eye on health metrics for conversion rates and gross merchandise value, which is simply number of sales. And we were to A/B test this during this season against Pega, and we failed. So we did not reach our initial target of performing within 90% of the one of Pega. And nevertheless, we had to move on. The year turned, and it was time to get smarter, and we were happy to build something really, something real. So we wanted to implement our ML dream, and the idea was that we wanted to train a binary click prediction model, again, starting simple. And if we could manage to train a model to predict the probability of a customer clicking on a banner, then we could take it as our next improvement onto the recommendation system. So we went on and built a proper data pipeline in Airflow, integrated into our Kotlin service, where we trained the model every morning, and it generated batch predictions statically every morning, and we basically used the same static predictions throughout the day. We got promising results offline, high recall and precisions, and we stuck into the same primary and health metrics. So we were very happy and excited to test our real thing with the data science model in production, and bang, the reality hit our face again. It failed. And we were very, at first, disappointed that what was really happening, but that's the target that ML should create more CTR than a statistical model failed, but we had to dig into the analysis of what actually happened, despite the better offline results that we got from ML model. The root cause analysis showed us that, again, render clicks, render views and clicks were sometimes missing, sometimes duplicated. So it was very bumpy, grumpy. And that really made the model very sensitive to that noise coming in, and the statistical model performed much more stable. But looking back at the data, we saw that wherever we had healthy render data, we had actually made 4% CTR uplift there. But with most of the time, with grumpy data in that period, we'd actually made 12% less CTR. So that was only the technical challenge that we were facing. Business challenges were even harder, and our stakeholders, the marketing team, who were using our recommendation system to deliver their banners to customers, they made this argument that, hey, we know our customers better. We know the banners that we are ensuring that reaches the right target audience better. So we want to have a sort of control over the recommendation system that you are creating. They wanted to have a manual impression goal for every banner as a cap or as a minimum guaranteed target. But to us, that sort of contradicted the idea of personalization. But also, they wanted to test their hypothesis. Every now and then, they came up with some hypothesis as a new target audience, let's say Gen Z people, and creating different variants of banners for those Gen Z people, and they wanted to see which variant actually works better for them. And they wanted to A/B test this. But for us, that meant that every time a hypothesis from marketing team came in, we had to take those features, apply some engineering on them, feed it to the model, train a new model with that feature, run an A/B test, let it run for a couple of weeks probably, until we measure the success of that experiment and we move on to the next hypothesis. And this process would go on and on, probably forever, which we thought would be very inefficient. So the realization was that what was the real intent of the marketing team? Did we have to just accept the full control they wanted to have on recommendation system, or did we have to find out what is the actual requirement? So the idea was that they wanted a way that they can find out which variation of banners that they create works best, so that they can take the causation of that better performing variation and take it for the next campaigns, that they can optimize their campaigns and variant creations better. So if you could find a way that we would create a large pool of banners with all sorts of variations, that they would put every banner they want to create and have them compete with one another against customers in production, without constant changes that we had to apply on models, then we would be able to meet their requirements, because they could easily see which variation of banners works best for which target audience they have. Another problem we were facing, and marketing was always bringing arguments about, was opportunity loss. They were like, hey, why do you underserve banners that are clearly performing well in production? Or why do you overserve banners that are not performing well? So we had to look back into the process of recommendation and see what's happening. So early in the day, we made our CTR estimations for banners. Here we see only 2 banners. In this case, we estimated the green banner to create 10% CTR and yellow banner to create 8% CTR. And because of the higher CTR prediction for the green banner, it was served almost 4 times. The impression is 4 million, so 4 times as much as the yellow banner. But during the day, that wasn't the case. What actually happened during the day, the yellow banner performed actually better. It actually got a higher CTR, 3.5%, which is higher than the green banner. But if we weren't to adjust to our predictions to the actual performance, to the real-time performance of them, we would be missing some of the clicks and conversions here. Because if we just insisted to our early in the morning predictions and kept ourselves blind to what's happening in real time, of course there was an opportunity loss. So when we did an analysis, we were actually losing 40% click and 44% conversion just by not adapting to real-time performance of the banners. So if we put these 2 problems together, the full control from marketing team, or have a large pool of banners compete with one another, versus these real-time adjustments, with a bit of research into the solutions and prior knowledge, we saw that multi-on bandits is exactly the tool we need to tackle these 2 problems. We chose Thompson sampling version. We don't want to dig deep into the algorithm, but it's good to note that the advantage of Thompson sampling is using beta distribution, which is a good way to model uncertainties. And the idea is that we want to find which banners do we have to exploit when we need clicks and conversions, and which banners do we have to explore when we are uncertain about the performance of them. So with beta distributions, the more you know about a banner, the more that banner has been served, the more views and clicks you collect from it, the narrower distribution and taller or higher peak you get from it. And the less you know about a banner, then the wider and shallower distribution you have. So whenever you want to sample or guesstimate some CTR performance from a banner, but you also want to maximize your chance of suggesting the best banner, then you have to exploit and sample from the tall distributions. And whenever you want to explore and give chance to underperforming or less certain banners, then you want to guesstimate or sample from the wide, shallow distributions. So the idea was that we wanted to still enjoy the relevancy that we learned from customer behavior in ML, but we wanted to add a new layer, multi-on bandit, on top of our model prediction to adjust in real time. And that would catch real-time behavior. So relevancy of customers to banner messages versus real-time behavior. So we wanted to A/B test this again in production against the previous random sampling directly from ML predictions. And the results were interesting.
Yeah, so we ran different experiments for top and flex banners. Here you can see the results of the top banner on top and flex banners on the bottom. Of course, the main metric is still CTR. You can see the blue line, the multi-arm bandit variant versus our old exponential weighted random variant, which basically was a little bit improved, but still random selection. And we can clearly see that multi-arm bandit was the winning variant, and the gap is even bigger for the flex banners. And that's because with flex banners, as you may remember, we had even up to thousands of the banners, so more choices, more opportunity for MAB to explore between the banners and try to exploit the better performing ones. And in the left, you can see the metrics that we discussed before were clearly improved, even up to 20% for flex banners. So it was a huge success for us. Everybody was happy, but of course, as we know in IT, no new solutions come for free. And we also faced again a new set of the challenge. And I think the most important challenge that we faced with multi-arm bandits was like trying to balance between exploration and exploitation. Here you can see our Grafana dashboard for top banner and flex banners on the web channel. Each line presents a banner that has been selected in real time at that moment. And you can clearly see, for example, for flex banners, the green line on top is the winning one. So this selection or this banner had better performance. And if we served it, we would get more clicks. But it also means that some banners would be underserved or not served at all. Or even at some points on top, you can see a blue line, which basically is like 90 to 95%. And within that period, basically most of the customers are seeing only one banner. But this was not what our team and marketing team was really wanted. So we had to look into several options on taking the control and balancing the exploration and exploitation. And after like implementing some solutions, and when we were ensured that everybody is happy with the new baseline, it was the time to get back to the marketing team, hear their feedbacks, and over several workshops that we had with them, we learned more about their marketing strategies. They even shared some brilliant ideas that at the moment we are implementing them, and we are busy with improving the MAB that we already have.
For us, it was a journey of bumpy data quality issues, organizational pushbacks, but our hope is that you can take away some practical lessons that you can apply in your own projects when you face similar challenges. For us, was mainly starting simple and avoid using overkill solutions. And we also learned that data quality matters much more than model sophistication. We don't have to always go for very sophisticated models, but instead make sure that we are feeding in good quality data. Saying no sometimes to business and pushback was also very important, and making sure that we can prove how technical solutions can soothe the pain points of business. But also the in-house expertise that enabled us to tailor it to our needs and integrate marketing strategies into our MAB rather than using an external expensive tool that we didn't know how it worked. And of course, we made Bol quite happy by serving millions for them. Thank you. I'm happy to answer any questions, if there is any. Yes?
Thank you. Yeah, really interesting talk. I've got a couple questions. What was the end performance against Pega? I don't know, maybe I missed that in the
when Pega is not in place anymore, we can't compare something that is killed and gone. And comparing the last year's performance of Pega to current year performance of MAB is not really comparable because it's different time, different number of customers, different number of requests, different campaigns. So we can't really compare it. But just the numbers show that we have better performance now.
Okay, gotcha. And when you're mentioning over-exploitation versus balancing exploration versus exploitation, like, I'm just curious, could you dive a bit more into that? If there's a banner that's outperforming like significantly, isn't that good? Isn't that what you'd like? Or is it because those click-throughs aren't actually leading to conversions?
Our team, the data science and software engineering team, thought that if we can find a winning banner and maximize our profit by selling much on that banner was actually a success. But marketing team and different business teams, they thought otherwise. They thought that messages and campaigns should reach relevant customers. So it's not only about sale, it's not only about clicks, but it's also about awareness that the marketing wants to create that for Bolt's customers. That's why it's now a matter of organizational decision on do we really have to take CTR as a success metric? So if CTR is the success metric, then finding that winning banner quite early in the day is a big success. But then the question of are we able to deliver our message while a winning banner is taking most of the traffic, then probably a lot of messages from different campaigns and banners are not reaching the relevant customers. So that's why we had to, if you notice, for example, that blue line on top, it's nearly taking 90% of the traffic for some certain hours. But in flex banners, you see that like the dominating banner is taking just slightly more than 15%. So yeah, that on top banner is more clear that one big banner on top is usually being the winner. But this is always a discussion at Bolt. But I think it's a matter of a will to challenge ourselves and move on from CTR.
Okay, thank you.
Okay. Here.
Yes, thank you for the nice talk. The multi-arm bandit model sounds really great. But it's basically exploration vs exploitation around that. Did you also look into more classical recommendation engine approaches? And how did it perform compared to this one?
As I said, we wanted to start simple and make our system. First of all, we didn't have a system. We just had a model at first. And then we had to make that model quite a system. And a recommendation system should be able to integrate marketing strategies into it to determine when a campaign should be prioritized over another one. That multi-arm bandit enables us doing that. But again, multi-arm bandit is just a layer, exploration, exploitation, adjustment over your recommendation model. So you could go with traditional setup, but still have MAB on top of it. But because we wanted to start simple and iterate and make progress over time, we wanted that every step means something to the model. So of course, this model keeps getting better and better, moving towards deeper models with ranking on top of it. But because that was out of the context, we did not explore that. But indeed, that's what the team is exploring.
Now we have time for one short question.
Why is the data so flaky or like going up and down from 2 o'clock to 6 o'clock? Is that because so little sales are happening at that moment, or why is it so like?
Yeah.
You want to answer that?
So in Bolt, sometimes if you are using the app, you usually receive a notification for fleet steal that happens around 7 p.m. until like 10 or 11. So that part, that blue part that you see is the effect of that notification being sent. But of course, after the midnight, the number of the customers are visiting website is reducing. And at some point in the middle of the day, the new daily predictions are published. So during the day, you can see that some banners are getting more interactions because of external effects like notifications, or if you compare day to day, could be the effect of the new sets of predictions, or sometimes A/B testing, new models. So several parameters can affect which banner being selected during the day.
And I want to add something. It also means that during that time, there is more exploration. So all banners equally are getting explored because we have less traffic, so it's good time to start exploring.
Okay, thank you for the wonderful talk from our speakers. Now we will have a 15 minutes talk, and if you 15 minutes break, and we will be back at 2:10. If you have any more questions, feel free to reach to our speakers during the break. Thank you.